Good day, grade 12. I welcome you to this session on trigonometry in 2 dimension and 3 dimension. Okay, the lesson is dated for 6 April 2020, which is today, and we are having this session, which was supposed to take place from 1 o'clock to 2 o'clock. Okay. Nevertheless, get your book as well as your scribbler, where you'll be writing your notes and solving the problems. Okay. Let us look at the lesson objectives. So we will be looking at the introduction to this topic. We'll look into revision from grade 10 and 11. We will deal with what we call angles of elevation and angle of depression. We will also deal with what we call the sine rule and the cosine rule, which are very important rules in trigonometry in 2 dimension and 3 dimension. Also, we will look at the area rule. Then we will go to summary of the lesson. Okay. Now let us start. In our introduction, we want to explain what is all about trigonometry in 2D and 3 dimension. Okay. Remember the trigonometry where we were dealing with your reduction formulas and all those stuff, including the right angle triangles. That is trigonometry in 1 dimension, and also you should take note that trigonometry in 2D and 3D mostly involves non-right angle triangles. Note it down. Trigonometry in 2 dimension revolves or is mostly about non-right angle triangles. Okay, very important. So I've drawn 2 triangles for you. Triangle ABC, there given to you. So what is the first thing that we need to know when we deal with trigonometry? We need to label the sides. Okay. And how do we label the sides? In trigonometry, we label the sides of triangles using a small letter of the angles facing that particular side. Okay. Like in the first case, we have triangle ABC and it's a right angle triangle. So side AB is faced by angle C or angle theta, and therefore we are going to label side AB with a small letter of the angle C. Okay, and then side BC is opposite angle A, and therefore we'll call it little a, etc., etc. Okay, and then that also applies to the non-right angle triangle ABC. Side facing angle A, we call it little a. Side facing angle B, we call it little b. And the side facing angle C, we call it little c. Now, when we are dealing with our right angle triangle in trigonometry, there are 2 methods that we can use in order to help us determine the sides of the triangle as well as the angles of the right angle triangle. And those 2 methods are trig ratios, your sine, your cos, and your tan, which comes from your SOHCAHTOA. Alright, this is what we did in grade 10. Theorem of Pythagoras, this is only applicable if you are looking for the sides of a right angle triangle. Okay, and how do we state the theorem of Pythagoras? It will be b squared equals to a squared plus c squared. The square of the hypotenuse side is equals to the sum of the squares of the other 2 sides. Alright, now let's look at the non-right angle triangle. When we are dealing with a non-right angle triangle, we can't apply trig ratios or theorem of Pythagoras unless it is a right angle triangle. Okay, so is it possible for us to find the angles as well as the sides of a non-right angle triangle? Yes. And what is it that we are going to use? we are going to use our rules, which we are going to look at next. Now, before we go to the rules, I would quickly like us to do this example, which is from grade 10. So we are given in the diagram alongside angle P is 40 degrees, QS is perpendicular, PQ is 10 centimeter, and QR is 18 centimeter. Determine correct to 2 decimal places. You need to round off the length of QS. Okay, now let's look at the triangle. The big triangle PQR is a non-right angle triangle. However, triangle PQS and triangle RQS are right angle triangles. Okay, meaning I can be able to apply my three ratios as well as the theorem of Pythagoras on the two triangles which are right angle triangles. Now for A, the length of QS, where is QS? Is in both triangles. Okay, but I'm going to use a triangle with most information, and that is triangle PQS. Now angle 40 degrees is opposite QS and is hypotenuse PQ. What is that? That is the sine trig ratio. So sine 40 degrees is equal to QS opposite side all over 10 the hypotenuse side, and we make QS the subject of the formula. We get 10 sine 40 degrees, and to 2 decimal places as instructed, that will be 6,43. And remember, it's the length of the side. Units are important, centimeters. Okay, now we go to B. The size of angle R. Remember now R is in triangle QRS, right angle triangle QRS, and we know what is QS, 6,43 centimeter, and we know what is QR. So angle R is opposite QS and hypotenuse QR. Okay, and that will be sine trig ratio. So sine angle R is opposite QS, where QS is 6,43 all over its hypotenuse to side QR, where QR is 18 centimeters. Then we take the arc sine, or we shift sine, the ratio of 6,43 over 18. Then angle R is 20,93 degrees. Well done. Now next, we want to do C. Okay, so what are we doing with C? Remember, we are asked to find the area of triangle PQR. What is triangle PQR? It is the big triangle. Okay, now we can be able to do that because remember, what is the base of a triangle? It is the side that is perpendicular to the height, or the height of a triangle will be perpendicular to the base of that triangle. Okay, so for triangle PQR, it means our perpendicular height will be QS and our base will be PR. Right, so it means the first thing that I need to do is to find PR, and that is by finding PS as well as SR, then that will give me PR. Alright, now let us try and do that. How do I find PS in triangle PQS? Obviously, 40 degrees, the angle 40 degrees is adjacent to PS, hypotenuse to PQ. That is cos trig ratio. When I go to triangle QRS, angle R is also adjacent to SR and hypotenuse to 18, meaning both of them will be using the cos trig ratio. Okay, now let us look at how I've done it. I said cos 40 degrees equals to PS over 10, the hypotenuse. Then we made PS the subject, and then we got PS to be equals to 7,66. Units important, centimeters. Okay, then I also found RS by using the angle R. So cos angle R, which is 20,93 degrees, equals to RS over 18, making RS the subject. Then I found RS to be 16,81 centimeters. So remember, units are important because RS is a length, therefore centimeters. Now, when I added PS and RS, I found that they give me PR, and which is 24,47 centimeters. Well done. Now, moving on, how do we find the area then? Remember, the area we said it's going to be half base times perpendicular height. What is our base? It is PR. What is our base, perpendicular height? It is QS. Therefore, half 24,47 times 6,43. Then our area was 78,67 square centimeters. Well done. Now moving on to slide number 8. We are now talking about angles of elevation and depression. That is our next discussion. So what is happening with our angles of elevation and depression? What is an angle of elevation? Okay. Now imagine that your eye is looking at an object somewhere up there in the sky. Okay. So what we do, we are going to say on the level ground of your eye, we will call that our horizontal line. Okay. And then to the object that we are looking at, then we'll be having what we call, this will be the line of sight. Okay. So between your horizontal and the line of sight, we'll be getting what we call an angle of elevation or angle of inclination, right? So that is when we are what? Looking at the object up above your horizontal. Okay. But on the other side, what is the angle of depression? Now, for my horizontal, okay, there's an object moving below the horizontal. Maybe there's a spider moving on the floor, and you want to look at the spider. Immediately you drop your eyesight below the horizontal, then you'll be looking at the object. So the angle between the horizontal and the line of sight down, okay, to the object, we call that the angle of depression. Please note, the angle of elevation may also be called angle of inclination. I have highlighted it here so that you know. Okay, so these mean one and the same thing, and I hope you are going to take note of that. Okay, well done. Now, the other thing that I want you to know is, note that the angle of elevation is always equal to the angle of depression due to alternate angles between parallel lines. Okay, so obviously what they are just saying is, if I have a Z shape like this one, and then this line is parallel to this line, therefore, if this is the angle of depression here, and then this is the angle of elevation there, then obviously if this line and this line are parallel, then we have this being equal. So that is what they mean. Okay, they are always equal because of alternating property. Okay, now let us go to the area rule. What is the area rule? Very important. Remember, when we are finding the area of a right angle triangle, we have the base, we have the height. But now when we're dealing with trigonometry in 2D and 3D, we are saying these are 9 right angle triangles. Okay, so what we only need is 2 sides and an included angle. Once we have that, then we can be able to calculate the area of a non-right angle triangle. Doesn't necessarily mean we must have a base and a height, but having 2 sides and an included angle, we may be able to what? To find the area of that particular non-right angle triangle. Okay, so we use the area rule whenever we want to determine the area of triangles which are not right angle triangles. Okay, so there I have given you 3 figures. Triangle ABC. We said what's the first thing that we do? We label the sides of the triangles with the small letter of the angles facing those sides. Okay, and that is very, very important. Now let's look at the first figure, triangle ABC, and I'm given angle A. So if I'm given angle A and I have side AB and side AC, which is little c and little b, can I be able to find the area of that triangle? Yes. There is an included angle and 2 sides which are given. So it will be half what? The 2 given sides, the product of the 2 given sides, B times C sine angle A. That's another thing that you need to note. When we are dealing with a right angle triangle, we don't necessarily need to include sine included angles, okay? But we just say half base times height. But with the area rule, there is sine the included angle, okay? That is the same thing that happens with the other two triangles. We'll be having those calculations in order to find the area of a non-right angle triangle, okay? Very important, please go through the proof. The proof is very important. You need to know how to prove the area rule, okay? Examinable. Moving on, we are going to look at examples now, given 3 problems as to how we apply the area rule, okay? Determine the area of the triangles shown below. Correct your answers to 1 decimal place when necessary, okay? Now the first problem, number 1, triangle ABC. We are given side AB, which is 6. We are given side AC, which is 8. We are given angle A, which is included angle. Why do we say included? It is an angle between the 2 given sides. Okay. Now, how do we find the area? Remember, this is a non-right angle triangle. Therefore, area will be equal to half AB times AC times sine angle A. Then when we substitute, we found that the area of triangle ABC in the first problem will be 12. Okay. But remember, AB has units. AC has units. So when I multiply a unit and a unit, I'm getting square units. Those are the units for area. Okay. Now, problem number 2, we are given side AC, side AB, but we don't have an included angle. Are we able to find that included angle? What is the included angle, by the way? It will be angle A. So yes, we can find angle A because we know what is angle C, what is angle B. Therefore, finding angle A will use the property of sum of angles of a triangle. So 180 minus 20 minus 23. Therefore, angle A is 137 degrees. And now we can calculate the area. It will be area equals to half AB times AC times sine angle included angle A. Therefore, when we substituted then, we found that our area for that particular triangle was 179,0 square centimeters. Why? Because the 2 sides were each measured in centimeters. So centimeter times centimeter, we are getting a square centimeter. Okay. And then now, lastly, we go to problem number 3. Okay. Now with problem number 3, we have a triangle ABC and we are given AC and BC, but we don't have an included angle. But what do we know about that particular triangle? This type of a triangle where we have an exterior angle of that triangle, we can be able to use that property and find angle C. What do we know? 140 degrees, which is the exterior angle of a triangle, will be equal to the sum of interior opposite angles, which is angle 78 degrees and plus angle C. Okay. Therefore, I found that my angle C would be 62 degrees, and I wrote a reason exterior angle of triangle. Okay. Now, after finding angle C, which is our included angle, with substitution, then I found that my area of triangle ABC was equal to 251,6 square millimeters. I'm using units that were used initially in the problem. So millimeter times millimeter is a square millimeter. Take note, I've rounded off to 1 decimal place where applicable, which was the instruction and very, very important. Okay, now moving on, we will look at the second problem. Determine the size or sizes of angle A if triangle ABC alongside, okay, has an area of 50 square meter. Remember now, here we are given the area of a non-right angle triangle. We have the 2 given sides AB and AC, and we are looking for angle A. We can be able to do that, but take note, what is our longest side? It is BC. So please note down, write it somewhere, very important. When we are calculating the angle facing the longest side of a triangle, we must always have two solutions. Okay, that is because your triangle may be an acute triangle and may also be an obtuse triangle. Okay, so we must always have two solutions, as well as when we are using our sine rule. This is very important. For cosine rule, please, we do not follow this. Only for the area rule, because there is sine, and also for the sine rule where we get sine. Okay, so we use the property that if I have a non-right angle triangle and I'm calculating the angle facing the longest side, then I'll have two solutions. Okay, let's see how we do that. So area is equal to half AB, AC, sine angle A. We are finding angle A. What is the area? It was given as 50 equals to half. AB was 10, AC was 20, sine angle A. When you divide everything by, is it 100? I think that will be 100. Okay, yes. Divide both sides by 100, then I'm getting a 1 over 2 sine angle A. Therefore, when I shift, I got 30 degrees. But remember, angle A is facing the longest side BC, hence I must have two solutions. Therefore, angle A can also be equals to 150 degrees. I got that by saying 180 degrees minus 30 degrees. Let us look at this diagrammatically. Okay, I think I will show you as we move on how this is determined diagrammatically. Okay, now we are discussing the sine rule. Okay, we are done with the area rule. Now we are looking at the sine rule. So with the sine rule, what is happening? Okay, the sine rule is only used when we want to determine an unknown side or an unknown angle of a non-right angle triangle. Okay, I think everything that we're doing now is based on a non-right angle triangle, so please note that. Okay, so we may be calculating the side of a non-right angle triangle or the angle, but you need to take note of the conditions that you must follow when you want to use the sine rule, and the conditions are given to you, and these are the conditions here. Okay, what are the conditions? Use the sine rule when you are given two sides and an angle that is not included, that is not between the given two sides. Okay, that's the first thing. If you are given two sides and one angle, that angle must not be an included angle. Or you may be given two angles and one side. Now with that one, there is no specification. You are just given two angles, one side, then you'll be finding another side. Okay, so this also is the proof of the sine rule, which is examinable. Okay, especially this one here is very, very, very examinable. You need to know how to prove, and this is the proof that you need to practice. Okay, now what is the formula for the sine rule? The formula then is given to you down here. Okay, this is the formula for the sine rule. Sine angle A is over little a equals to sine angle C over little c. Okay, or sine angle A over little a is equals to sine angle B over little b, or sine angle C over little c equals to sine angle B over little b. Okay, so whenever you are dealing with this formula, you only take each of those. Where you work with two ratios. Okay, either sine angle A over little a equals to sine angle C over little c, or the other one. Okay, you don't write the whole formula as I've circled it in red. Okay, now let us look at how we apply the sine rule. Okay, before we go to that one, I want you to note here what I've written here, the ambiguous case. When solving for an angle in a triangle, it is possible for there to be two possible solutions for an angle. Okay, this occurs when the angle we are solving for is opposite the longest given side. I've already said it. Please note it down very, very important. Now, let's look at the illustrative example. Solve for angle P in triangle PQR below. What is angle P? Angle P is unknown, and that's what we are finding. And this angle is facing the longest side of that triangle, which is 100, bigger than 60. And then we have angle R, 25 degrees, facing 60, which is the length of side QP. So since angle P is facing the longest side, it means we're going to have two what? Answers for angle P. So using the sine rule, sine angle P over little p, or you can say over QR, is equals to sine angle R over little r, or you can say QP. Substituting, I found that my angle P was equals to 44,78 degrees, but because angle P was facing the longest side, therefore angle P is also equals to 135,22 degrees. Well done. Now, let us go to the cosine rule. With the cosine rule, okay, before you go to the cosine rule, please note here, this is the grammatical representation of why we have two solutions for angle P. The other angle, which is 135,22 degrees, may be an obtuse angle. Okay. Now, let's go to D, which is the cosine rule. Now, the cosine rule works in the same way as the sine rule, but there are conditions for you to use the cosine rule. What are the conditions? Let us look at this part here. This is the condition here for you. Okay, let us look at the condition. Only use the cosine rule if you have a triangle where you are given all three sides. Do we have that with the sine rule? No. But here, if you have three sides that are given, then you know cosine rule is a way. Or two sides and an included angle, underline, and an included angle. If an angle is included, remember with the sine rule, angle must not be included. But with the cosine rule, the angle must be included. And we are given the two other sides, you'll be finding the third side. What do? Then you use your cosine rule. Okay. And usually, if a side of a triangle has a square root in it, usually we use the cosine rule. And that is because it involves the squares in the formula. Okay, let us look at the sine rule. We use this when we have a non-right angle triangle and satisfies those conditions. Triangle ABC, I'm given side ABC and an included angle A. Therefore, the formula will be A squared equals to B squared plus C squared minus 2BC cos angle A. What I want you to notice is the side, which is the subject of the formula, will also be taken with its angle. In this case, side, which is the subject of the formula, is a small a, and its angle is angle A. Okay, let's look at the second diagram. I'm given side ABC and an included angle, angle B, between side A and C. So when I look at this one, which side is my subject of the formula? Will be B. So we'll be having B squared equals to A squared plus C squared minus 2AC. And then we take what? The angle facing the side that is the subject of the formula, that is cos angle B. Next. Okay. Now, this proof here, very, very important. Actually, all the three proofs, the area rule, sine rule, and the cosine rule, are examinable. And we will always ask you to prove either the sine rule or the cosine rule. The area rule, yeah, but we don't usually ask for that. Please know how to prove the sine rule and the cosine rule, especially this proof here, which is also found in your textbooks. Okay, 5 marks. Now, let us look at how we apply the cosine rule. Okay, determine the length of BC. Do you see BC? Okay. In triangle ABC alongside. So what is happening there? We have triangle ABC with AB and AC given sides and an included angle. Included because there's an angle found between the two given sides. So how do you find BC? Okay, because this satisfies the conditions, we are using our cosine rule. So BC squared will be equals to, alright, B squared, which is side AC, plus C squared, which is side AB, minus 2BC cos angle A. Substituting, I found that my BC squared equals to 2219,25, and when I take the square root of BC squared both sides, then BC was equals to 47,11. Remember, BC is a length of a side. That's why we must put in units that were used in the diagram, and that is centimeters. Okay. Now, looking at the second problem, example, determine the size of angle B. Okay. Although angle B is facing the longest side of the triangle, here we don't use the property of two solutions, only with what? Where we see sine as in the area rule and the sine rule. Okay, so here we only have one solution for angle B, and we are given three sides, and that is the condition for using the cosine rule, and therefore our remember, you can write down your formula first and then substitute, then make cos angle B the subject, but I simply wrote it this way. Okay, you don't need to claim this. You can write the original formula, then make cos angle B the subject. So with mine, I substituted them. I found that cos angle B is equals to negative 0,027. Cos of any negative angle is a positive, that angle. So I'm not scared of the negative. And therefore, when I shift cos or take the arc cos of negative 0,027, angle B was equals to 91,55 degrees. Well done. Okay. Now, let us go to example 2. What is going to happen here? You want to see whether you can relate and match those rules to this problem. Which one will work for this problem? In the diagram below, determine the length of CD. Do you see CD? Okay. It's in triangle ACD, 9 right angle triangle, ACD. Triangle ABC is a right angle triangle. So we are finding CD. How do I find CD? I've got two angles given, but no side. But I can use the right angle triangle ABC to at least find one side, and then I can use it with triangle ACD. Which side relates to both the right angle triangle and the non-right angle triangle? Is side AC. Let's find AC first. So in triangle ABC, angle 55 degrees is opposite AB and its hypotenuse AC. So I made AC subject of the formula after substitution. Then I found that AC is 41,51 units. Remember, its length units are important. Now that I have AC, I can find CD. Why? Because CD is facing angle 35 degrees and angle D, 74 degrees, is facing AC. What is that? Two angles, one side, and that side is just a side. That is the sine rule. Okay, so CD all over sine 35 degrees equals to the 41,51 all over sine 74 degrees. Okay, now CD is therefore equals to that, and I found that my answer was 24,77 units. Okay, done. Well done. Now let us go to another problem which I have screenshot from my phone. A triangular advertising banner. Okay, triangular advertising banner is erected between two poles and secured to a point on the floor as shown in the diagram below. So the two poles is AD and CE. The triangular advertising banner is ABC and erected between the two poles. So it is secured to a point on the floor. That point is point B, where we get angle theta. Okay. For stability, a steel wire is run through the perimeter of the banner. Okay, that's not important. Now AD is given as 18 meters. Angle B in triangle ADB is 44 degrees. Angle B in triangle ABC is theta. Angle B in triangle BCE is 64 degrees. And side BE is 14 meters. Triangle ADB and triangle BCE are right angle triangles, where triangle ABC is a non-right angle triangle. Okay, now if one side of the banner is to be painted and 1 can of paint covers a surface area of 35 square meters. Okay, how many cans are required? So the first thing that you need to know is the total area of the whole banner. Okay, size of a banner. And how do we find that? Let's look at the top there. Sine 44 degrees. I'm using triangle ADB. Okay, so sine 44 degrees equals to 18 over AB. What am I doing? I'm first finding side AB, then I'll go and find BC, then I can be able to find the area having found also theta. Okay, so AB happened to be 25.91 meters. Then I move to the right angle triangle BCE. So I'm using cos because 64 degrees is adjacent to 14 meters and hypotenuse to BC. Therefore, BC happened to be 31.94 meters. Okay, now I've got side AB, side BC, and I need to know what is theta before I can use my area rule. How do I find theta? 44 degrees, theta, and 64 all lie on a straight line. So theta will be equals to, I found that theta was 72 degrees because of the property of angles on a straight line. Okay, add up to 180 or a supplementary. Now using the area rule, half. Why am I using the area rule? Because triangle ABC is a non-right angle triangle. So half 25.91, 31.94 sine the included angle 72 degrees. The area was 393.53 square units. Units important. And then now I want to know how many cans of tin will actually paint the banner. So it will be 393.53 over what? The 35 square meters that we were told about, and therefore n is equals to, n stands for the number, okay, number of tins. So n is equals to 11.24. So remember, we need to know how many cans or how many tins will paint the size of a banner. Okay, so 11.24 will be the exact amount, but when I round off to the nearest, that will not be true. You can't say n is equals to 11 and then say 11 tins, because some part of the size of the banner will not be painted. Okay, rather n will be approximately 12 cans or 12 tins of paint. That is because we'll be left with some of the paint after painting. Yes, good. Now note this. Please go through this and then make sure you understand what I said there. Okay, now let us look at more conceptual problems. Show that the length of BC, do you see BC? There is BC there. Okay, show that BC in the diagram can be found or written like that. Okay, what I'm noticing is I have a lot of information on triangle ADC. Okay, by the way, triangle ADC and triangle ABC are non-right angle triangles, but I have a lot of information on triangle ADC. And the first thing that I'm noticing is side AD and side DC are equal. That is the isosceles triangle. Therefore, angle C in that triangle will also be alpha. I wrote it down. Okay, and if angle A and angle C in that triangle are both alpha, then I can find angle D using sum of angles of a triangle, and therefore angle D is 180 degrees minus 2 alpha. Okay, so what relates triangle ADC and triangle ABC? Since BC is in triangle ABC, it is side AC. So the first thing that I need to do is to find side AC. Okay, so side AC is facing angle D, which I know, and then I have angle A in triangle ABC facing side DC. I can find AC. Okay, so AC over sine angle D equals to DC over sine angle DAC. Remember, I'm using the Sine Rule, okay, because I'm looking at the conditions. So my angles my side AC then happened to be, let us look at the next slide. My side AC happened to be x sine 2 alpha over sine alpha. I know some of you might expand the sine 2 alpha using the double angles, That's not a problem, but let us look at what we have in the proof. We have a sine 2 alpha, okay? So if you expand that, then you are losing your sine 2 alpha, okay? Now, having AC, going back to the diagram, what is happening? I'm looking for BC, but I have AC, and AC is facing angle B, which is beta, and then angle A in triangle ABC is facing BC. So I can use my sine rule again. Oh, wow. Therefore, I'll be saying BC over sine, remember, side BC is facing theta, okay, angle theta, so BC over sine theta equals to AC over sine beta using the sine rule. Therefore, cross multiply, make BC the substitute of the formula, and by substitution AC, then I found that my BC was X sine 2 alpha sine theta over sine alpha times sine beta. Okay, well done. Now moving on, we're looking at another example. Okay, we are given a diagram below. The angle of elevation, remember now we need to go back and understand what an angle of elevation is. It is the angle between your horizontal and the line of sight up to the object. Okay, so the angle of elevation of R is from Q is alpha. Okay, this is what they are talking about there. And the angle of elevation of Q, okay, from S is theta. This is what they are talking about there. Okay, if PS is X, okay, and angle R is beta, prove that SR, okay, prove that this side here, SR is equal to that whole thing, okay. Now the first thing that I want us to look at is, do you see Q1, angle Q1? Okay, angle Q1 and angle PSQ are both equal to theta. Why? Alternate angles. Remember, angle Q1 will be angle of depression of Q, whereas angle S will be angle of elevation from S to Q. Okay, so those two are equal, alternate angles. Now I've wrote it down. Angle Q1 equals to theta, and therefore now I'm starting by working on triangle QPS, because side QS will relate with the non-right angle triangle QRS, where then I can find SR. Okay, so in triangle QPS, angle theta is adjacent X and hypotenuse QS. Therefore, finding QS, I found that QS was X over cos theta. Then I use my QS, which is facing angle R, which is beta, and angle Q, which is alpha plus theta, facing the side that I'm looking for as R. What rule can I use there? I can use my sine rule again. Okay, so SR all over sine the angle facing SR, which is alpha plus theta, is equals to QS all over sine the angle facing QS, which is beta. Okay, so there we go. I know what is my QS from the top. I substitute it. QS is X over cos theta all over sine beta. Then I made SR my subject of the formula, and then I got exactly what they've asked us to find in this problem. Well done. Now let us go to another problem. This is taken from a past exam prelim paper, your preparatory examination. So you need to make sure that you understand how we answer the questions. Now PQ, okay, and AB are two vertical towers. Okay, from a point R, okay, please check R, in the same horizontal plane as Q, meaning they lie on the surface, both of them, as Q and B, the angles of elevation to P. Okay, look at the angle of elevation to P. What is that? It is theta. Okay, and angle of elevation to A. What is that? Look at that. It is 2 theta. Okay. Now, angle AQR, you see AQR, they've drawn some arrow lines, which is so nice, equals to 90 degrees plus theta. That is for you to use. And then angle QAR, do you see QAR? There is like on a slide, okay, is theta. Side QR is equals to X. Now, you need to determine in terms of X and theta, the length of QP. What is QP? QP, please look at QP. Do you see QP? QP is right here. Okay. How do I find QP? First of all, triangle QPR is a right angle triangle. And angle theta in there is facing side QP and is adjacent to side QR. What is that? That is the tantric ratio. So tan theta is equals to QP over X, making QP the subject of the formula. Then I found X times tan theta equals to QP. Well done. 6.1.2. Now we are looking for AR. AR is in the non-right angle triangle QRA or QAR, and we can find it. Okay. What do we have? We have 90 plus theta facing AR. We've got angle theta facing QR. Now we have what? We have two angles and a side, and we are looking for another side. We can use the sine rule. So AR over sine angle AQR in the non-right angle triangle is equal to QR all over sine angle QAR or angle A in that triangle. Okay, then with substitution, I found that this is what we have. Okay, and then I cross multiplied. Remember, sine 90 degrees plus theta, we use our cofunctions and reduction formulas. 90 degrees plus is in the second quadrant, where only sine is positive, but I have sine. I'm happy my answer will be positive. But 90 plus changes my sine to cos. Okay, hence I will get cos theta multiplying with x, then all over sine theta. Okay, therefore, what is sine theta over cos theta? It is equal to tan theta. But what is cos theta over sine theta? It is the reciprocal, the opposite, right? So that will be 1 over tan theta. So x all over tan theta. Okay. Now let us go to 6.2. Show that AB, where is AB? There is AB there. Okay. Show that AB is equal to 2x cos squared theta. Okay. So AB is in the right angle triangle ARB or ABR, and we know what is AR, and we are looking for AB, but we have angle R in that triangle, which is 2 theta. We can use our trig ratios. Okay. Now, 2 theta relates to AB such that it is opposite, and then it is hypotenuse to AR. Okay. That is our sine trig ratio. So how do we find our AB? It will be sine 2 theta equals to AB over AR, and then by substitution, AR was x over tan theta, if you still remember. So x over tan theta will multiply with the 2 sine theta, but remember tan theta would be sine theta over cos theta, and therefore the sine theta and the sine theta will cancel. Then I'll be left with 2x cos theta over 1 over cos theta, because the sine theta and the sine theta cancelled. But remember, 2x cos theta divided by 1 over cos theta, when I multiply, the cos theta goes up and then over 1. Therefore, I'm getting 2x cos theta times cos theta, which is 2x cos squared theta. Well done. Now let's go to 6.3. Determine AB over QP. This is like a ratio. Find the ratio of AB is to QP. if theta is 12 degrees. Obviously, they are giving you theta so that you will substitute the theta. Okay, so when I go to that one, AB over QP, remember we know what is AB. It is 2x cos squared theta. We just found it. And we also know what is QP. We found it at the beginning, which was x tan theta. When you put theta as 12 degrees, then the answer is 9. Just punch in your calculator. Okay, well done. Now, we are going to the last problem of our lesson on trigonometry in 2 dimension and 3 dimension, and I hope we will understand. So I have a nice scenario here with a rat, with an owl, with a cat, and let us see how the problem is given to us. So a mouse, okay, so a mouse, we are given a mouse, there's the mouse, okay. On the ground is looking up to an owl in blue, an owl, there's the owl in a tree, and a cat to his right on the ground, so to the right of the mouse. So I'll use green for the cat. Okay, there is the cat. So red is the mouse, blue is an owl, green is the cat. So what is happening here? They are saying the angle of elevation. You see, it's important that you know and understand what is an angle of elevation. Okay, angle of elevation from the mouse to the owl, is 90 degrees minus 2 theta. AM is given as K units, GC 8 units, MGC, what is that? The angle G in triangle MGC, 150 degrees, and MCG in triangle MGC again is theta. Angle C is theta degrees. Now, triangle AMG is a right angle triangle. Triangle MGC is a non-right angle triangle. Okay, very, very important. Now, give the size of, that is 7.1, MAG, angle MAG, the angle between line MA and line AG, meaning that's angle A there at the owl. How do we find angle A? We know what is angle AMG. We know what is angle G. Therefore, A will be a completion of 180, isn't it? So, we can find angle A. So, 180 minus angle AMG minus angle G. And we found that angle A will be 2 theta. I didn't write it down. Please do write it down. And my reason was sum of angles of triangle. Okay, 7.2. Show that MG, okay, this is like a proof that. Show that MG, which is in both triangles, will be equal to that. Okay, so I see where I have K. K is in the right angle triangle, and 2 theta is also there, so I can use the right angle triangle. So MG and AM, how do they relate to the angle that is there? Okay, so angle A is opposite MG, is hypotenuse AM. That is the sine trig ratio. So sine angle A equals to MG over AM. Substituting sine 2 theta equals to MG over K. Then I prove that MG is equals to K sine 2 theta as they've asked. Okay, there we go. So MG equals to is equals to K sine 2 theta. Okay, now let's go back to 7.3. 7.3, they are saying show that MC, do you see MC? Between the mouse and the cat. Okay, the distance between the mouse and the cat. Show that MC is equals to K cos theta. So that is simple. MC is in the non-right angle triangle and is facing the angle 150 degrees. And then angle C is theta facing MG, which is just what we found. This satisfies the condition of the sine rule. Okay, So MC over sine 150 degrees will be equal to what? Will be equals to mg, which is k sine theta all over sine angle c, which is sine theta. Okay, let us write it down and see how we solve that. Okay, so there we go. MC over sine g, angle g, equals to mg over sine angle c. Substituting, remember angle G in that non-right angle triangle was 150 degrees, which can also be written as 180 degrees minus 30. Why 30? Special angle. Okay, now 180 minus second quadrant where sine is positive, therefore I'm getting sine 30 degrees. So making MC subject of the formula, I'm getting k sine 2 theta times sine 30 degrees all over sine theta. Okay, this is very, very important. Now, what is sine 2 theta? It is 2 sine theta cos theta. Therefore, the sine theta and the sine theta cancelled, and the sine 30 degrees, when you use your special angles, became a 1 over 2. So 2 times 1 over 2 is a 1, and we were left with k cos theta. Have we answered the question? Yes. We were also showing that MC is k cos theta. Last question. Show that the area of triangle MGC, the area of the non-right angle triangle, will be equals to 2k sine 2 theta. Alright, that is very, very, very simple. Remember, with the area rule, because we use it in a non-right angle triangle, you need to have two given sides and an included angle. Okay, so let us see how I've worked it out. So this is what I've done. I've said 7.4 area equals to half mg. Remember, I know what is mg times gc. Remember, I'm given gc. What is the angle between them? Let us look into the sketch. MG, GC, the angle between them is 150 degrees, and it is the included angle. Okay, so if that's the case, then what am I getting? Obviously, I'm getting half k sine 2 theta times 8 times sine 150 degrees. But remember, sine 150 degrees is the same as sine 30 degrees. Okay, these are what we call conterminal angles. Okay, they give the same answer. It's like sine 45 degrees giving you 1 over root 2 or root 2 over 2, and cos 45 degrees giving you the same answer. Those are complementary angles. Okay, now area is equal to, so the 4.5 multiplied, and they give us 2 what? 2k sine 2 theta. Alright, now summary. Let us summarize our lesson. We dealt with right angle triangles and non-right angle triangles. We said with the right angle triangles, two methods: trig ratios, theorem of Pythagoras. With non-right angle triangles, area rule, very important, sine rule, cosine rule, and the conditions for each for you to use any of the rules. Right? With a right angle triangle, if you want the area of the right angle triangle, it's half base times height. No sine included angle. Okay, and then the other thing that we spoke about, we said there's an ambiguous case. Please look at this one. There's an ambiguous case when we are using the sine rule and the area rule. That is when we are finding the angle facing the longest side of a triangle. We are finding the angle facing the longest side of a triangle. So you'll have two solutions. Okay. Then we also spoken about angle of elevation, or what we call angle of inclination. All right. We said those are the same thing. Now, what is the angle of elevation? Angle between your horizontal and line of sight up to the object. Okay. And then if I have my horizontal and line of sight down to an object, that is my angle of depression. Angle of elevation and angle of depression always equal because of their alternating angles. Okay. And that brings us to the end of our lesson. I hope you are going to listen to the voice note or this recording and meditate on it until you understand this concept. Very easy, and these are easy given marks. Okay, these are giveaway marks in the exam. Good luck.